there are several ways to produce heat. For example, the easiest way, the electrical heater.
Yeah, of course.
Compared to the heat pump, this seems to be much easier.
Yeah.
What are advantages of the industrial heat pump?
Of course, it seems on the first glance, it seems much easier to just use an electric heater and turn the electricity directly into heat for the process. There are no moving parts, or virtually no, and the heat pump, of course, is much more complex and, of course, also costly than an electric heater. But there is something that can turn this picture upside down. That is the efficiency of the heat pump. It's called COP, and COP is an abbreviation for coefficient of performance. And this means for 1 part electricity, 1 kilowatt hour, you get X parts heat out. And X is normally something between 2 and 6. So electric heater, the COP is always 1. What you put in, you get out. On a heat pump, you put something in, and by the factor of the COP, your output is larger. So a heat pump gives you much more output, of course, at a higher complexity.
Okay. And in a heat pump is a whole system. What is our role in this whole system? What do we as Atlas Copco supply for a heat pump?
Yeah, of course, you know, we are turbo compressor maker and a maker of large industrial gas equipment. Therefore, of course, our share in this is the core equipment, the compressor itself. We are one of the big makers of industrial turbo compressors, and of course we want to utilize our turbo compressor know-how here, and in fact it's a pretty good fit because those turbo compressors are great for large powers and are great for large durabilities, like many years and decades of operation time. This is all something that is very important if you're going into the industrial sector. Something that just lives 5 years, you will not be able to sell that. But something that is good for 30 plus years, that's the role of a turbo compressor then.
So a heat pump system contains of several components.
Sure.
What is our role in this heat pump system?
Yeah, of course a heat pump, as you said, is like the big brother or sister of a fridge. And the key component is always the turbo compressor in our case, because we are a maker of industrial compressors based on the turbo principle, and the turbo compressor is the main driver of the system that brings the gas from low pressure to high pressure. So our role is the turbo compressor of it.
Why should a potential user rely on the turbo compressor technology and not on other comparable compression technologies?
You mean something like screws and pistons and so on?
For example.
Yeah. Of course, the one thing is that the size limits those technologies. When you're in a lower power range, below 5 megawatts, then of course you can use screw compressors, piston compressors, whatever you want. But once you're above a certain limit of power, then of course you cannot put 20 compressors in parallel if one large turbo compressor could do the same service. So at one point, the turbo is simply the better choice in terms of machine size and the economics of it. And on the other hand, those technologies we've mentioned now, pistons and screws, they always have a certain amount of wear in the machinery because parts are touching in there. In our turbo compressor, the compression happens without anything that touches metallic parts or other parts. This means the technology is very, very reliable and has a very long lifetime once it's started up. This means there are machines in operation that are 30 years and longer, running without major overhauls, and the technology we offer here is simply the best choice for long lifetime, efficiency and large power ratings.
What are the critical sizes and temperatures for our turbo compressor?
Okay, also you mean that when you're in the larger power range, you have of course the demand to meet of the individual customers, and at one point if the power level is too small, then of course our machine is kind of over the top. I would say if it's below 5 megawatts, it's not a natural fit for our industrial heat pumps, while if it's below a certain temperature level, like 80 degrees, it's still not a good fit. But once we're in the sweet spot between 5 megawatts and 50 megawatts, and somewhere between 80 degrees and 300 degrees, then we're in a sweet spot where our turbo machinery and the heat pump around it is a great fit.
So we are the supplier for the compression unit, for the turbo compressor, for the heat pump.
Right.
But how are we able to supply the whole heat pump system, including piping, evaporator, condenser, and so on, to our customers?
Do you mean like if I were a customer and you were Atlas Copco and I ask you, can you deliver a whole heat pump system, what your answer would be?
Yes. Are we able to do this? Or?
Yeah, of course we are able to do this. First of all, we have to understand that we want to focus ourselves on the key areas we are really strong at, and that is making the turbo equipment, as you said. So we will not bring ourselves in a situation where we have to build a whole plant, but we partnered up with an EPC expert company from Germany that is able to fulfill exactly this role, to take on the project beyond our limits. And that is in fact a company that is based in Germany, Strabag Umwelttechnik. And this company is well known for environmental technology. They're making biogas systems, geothermal power plants, and other technical larger facilities. And with their help, we can deliver the whole turnkey system in any configuration the customer asks us for. So with that, we can deliver everything from the first planning to the ready commissioning of the plant and beyond.